Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rockets' red glare, the bombs bursting in air, gave truth through the night that our flag was still there. Oh, say, does that star-spangled banner yet wave o'er the land of the free and the home of the brave.
Ladies and gentlemen, welcome to Job Shop USA. All right, we're in here at the WAZER. We're getting ready to run the WAZER because we're going to cut the brake lining for our drum brake for Pearl. All right, now you know that this is a pretty firm material after I've taken it out. My first thought was to get brake material and roll it around here like a brake drum. This is a pretty small diameter, and the thickness of the material is needed because it's a wedge shape. But the bore is straight, and the taper or the wedge is all on the outside. The material come in a sheet, and that's what I have in there. I have a 1-inch sheet. This is less than 1 inch, but it's close to it. So we're gonna have a little extra material off of here as well, so that both surfaces, top and bottom, are flat. And we're just gonna cut out with the water jet an inner diameter and an outer diameter, creating a ring of material. We've already got our slab of material in here, and we're going to be cutting out a ring just about in that location right there. And there is no settings for this material, but I picked carbon fiber of this thickness to be the attempt, and I'm going to be paying attention to how fast it actually pierces through this material, and that'll give me an idea of making a custom file for this material if it needs to be other than or even faster than what it takes to go through carbon fiber material. All right, let's go in and take a look at the particulars for the cut, the abrasive use, and timing. I'm cutting it in the coarse because I really think that it's going to cut probably even easier than what it says for carbon fiber material here, 1 inch thick. A little over 3/4 inch per minute. Estimated job about 29 minutes, and estimated abrasive about 9 pounds. The total cost of this cut will be $7.71 in abrasive materials. All right, and then of course the size of the extent of cut area. All right, let's go cut it. I've got my stopwatch here, and I've got this camera set up, and I'm just going to be doing a video, and then I'll go ahead and make it cruise a little bit faster, because we know this cut's going to be like 29 minutes. Also, to anybody that's worried about their brake lining material dissolving in water, next time you go through a water puddle, you can go out and see if your brakes on the car are melting down. All right. Okay, looks like a ring. Looks like we have a little sand all over the place. Let me stop my camera here. Okay, and I'm going to pull that out of the way and rinse her off. Okay, let's see. I see a little bit of little tiny bit of breakage right at the beginning of that. Okay, that looks good. Let's see. There we go. How cool is that? Awesome. We're going to try a little bit of a lead in, a lead out on the next ones here. That surface actually looks pretty good. I don't know if I'd want to speed that up any more than it is. Pretty cool to get that ring in that shape without having to do all that machine work and creating and breathing all that dust. I took our ring and I just blew it off with the air, and it evaporated all the moisture in it. Here's the center plug I pulled out of the center of it. That's not blowing off, but you can see that the water does evaporate real fast. Let me grab my air nozzle here. Okay, so it doesn't retain water. This material is a medium friction brake lining material. It's good for 5,000 feet per minute at 500 psi, 550 degrees Fahrenheit, maximum operating pressure 500 pounds per square inch. The cohesion of friction is 0.35. The high friction sheet, which I couldn't get in this thickness, everything was exactly the same except for it had a 0.55 on the cohesion of friction. So hence my choice of material here. All right, so all we got is a light skim to get it to go over the bore. We're going to decide whether we're actually going to take a split on it or if we're going to leave it solid. I don't know what the shape of this was in the form, the way it was. It is riveted onto here, and I want this to be just a real snug fit on here. And so we'll do the bore. We'll mount it on here. We got to do the rivets. We got the rivets in stock already, but we got to drill through from the inside. That's a pretty small diameter to get in there and drill through. So we're gonna trick our drill in there, and then once we have it on the outside, then we can set it up and we can do the counter bore for our rivets to sit in. And then we'll be able to mount this onto the hub and then turn this angle. This angle will be turned the same time we turn the bore of the female, the cup, the brake cone, so we have matching angles. The second, we did the timing on the pierce for the inside one. When it came to the outside, I timed that pierce. The inside one I timed at 46 plus seconds. The outside one was 57 plus seconds. The file said for the carbon fiber at 103 seconds. So we're just a little over taking half of what the carbon fiber would take as far as the piercing time. But I look at the cut and I like the cut. So I don't know if I'd change that at all. I was happy with my choice of where to start with the cut for this. I don't think I was that far off. And I think this material is a like material to the carbon fiber. Just my experience of 3D printing it and also turning and machining brake lining and brake material is also the same thing. Like a little close up, you can see the little chippies right there, and actually there's probably another piece there. I don't know if I can pull that up there, but you can see. Now, as far as this thickness goes, you're still way above it. I'm not worried about the chip out on it. It's a pretty clean cut. Inside as well. We got in our bushing material and we put it in on a little nub and a center in here, and we turned the outside of it to get that press fit right there. This is a long drawbar off a mill set here we got, and we're going to stick this in here. It happens to be the right size with a couple washers in here. We'll put one washer over on this end here. Screw that nut all the way on. We're going to put this stack up here, and we're just going to draw the stride in with 2 wrenches here. Okay. All right, we're going to slide in our new shaft. Okay, it is a little tight in here. We're going to run a reamer in there. Oh, there it goes. Oh, that is a good fit. Huh? Must have just been something on this end of the rod here. Oh. Who knows what? Oh, maybe it picked up something when I was sliding it through the bore. Regardless. Okay, there's no play on that now. You saw how tight that is. Awesome. After we dialed our super spacer in here and we mounted this up to where we had the good contact out here, we wanted to catch this outside ring here so we weren't just hanging out on the end of it. To have enough clearance and come in so that we keep our woodruff key chucked up on here, we went ahead and pulled out our masking plate so we can hit that oddball tooth there to clear this jaw all around here. But we got down in there and our woodruff key is all done and nice and tight here. There we go. All set. We got the K&T 3 jaw in here, and we're dialed in X and Y, and this thing is really sweet to have this capability. Even out there, this is running within 1,000s right now and in line. All right, now we're ready to start turning some parts. This is going to determine the bore of our brake liners, okay? And we're going to turn those first. So we want to turn the bore and the back surface, then we know the thing fits on here. We're going to mount those up, rivet those on, and then this will mount onto that hub that we just put the woodruff key in. After we have that one done, we're going to set this head up at the angle that we want to machine the cone and the cup, and we'll machine them to match. So that's what this is all about over here. All right, that's kind of wrapping up all the little extras that we were able to do on Pearl in between our regular work today. So until next time, thanks for visiting Job Shop USA. Get her done. Pretty true running water jetted part there.